All right, so again, we're going to talk about reducing margin of error. So it says female leads. 5 students wanted to see how many children's movies have female lead characters. They each took a sample of children's movies, found the proportion of movies that had female lead characters, and then used the result to simulate 100 additional samples. The table shows some of the findings based on the original sample and simulations. So what do you notice, and then what do you wonder? So first thing that I notice is that C had the biggest proportion, but they're all roughly around the same area, right? Like 20 to 30% are actually female leads in children's movies. So I wonder how that affects our children, right? So that's how you can do your notice and wonder. You could have noticed and wondered something else. Okay, look at how this is my smallest margin of error. Okay, so that's got the closest and narrowest. And then this has the greatest margin of error. Okay, and then look at the proportion. So our true mean is probably going to lie somewhere around 0.2, right? All right, so let's go ahead and look at today's stuff. So it says, Elena and Claire are each working on a project about how high school students are having trouble finding jobs. They each find then use a computer to do 1,000 simulations using the proportion they found and report the results. Elena says the proportion of high school students without jobs is about 0.7 with a margin of error of 0.280. Claire says the proportion of high school students without jobs is about 0.7 with a margin of error of 0.138. Both students reported the margin of error based on 2 standard deviations from their simulations. What are the mean and standard deviation of what each student found? Okay, so we learned yesterday. Okay, so what we're going to do is we're going to take this proportion right here, and we're finding the standard deviation. So since this is a proportion, we're going to use sigma p hat. Okay, so we're going to take the square root of p times q divided by n. So what we're going to do here is we're going to take the proportion that they give us, which is 0.7, and then we're going to take 1 minus 0.7, and we're going to divide it by 1,000. So really this is going to be square root of 0.7 times 0.3 divided by 1,000. And so when we put this in our calculator, we're going to get 0.0145. And that's going to be our standard deviation. I apologize. One of the great things about this is since our proportion, our p is equal to 0.7, our mu is going to be equal to 0.7. Okay, so our mu of our proportion, that means our mean of our proportion, is also going to be equal to 0.7. So what I'd like for you to do is go ahead and try to set up Claire's. Okay, so you're finding the standard deviation and then finding the mean. Okay, so again, we're going to use sigma of the proportion is equal to p times q divided by n. So we're going to have 0.74 times 1 minus 0.74 divided by 1,000. Okay, so when we put that into our calculator, we're going to get a standard deviation of 0.013 or 0.014. Let's do all the way out to 9. Okay? And then remember, our mu of our proportion is going to be 0.74. Okay, so I'm writing this information down here so that we have it, 0.0145. Okay, so Claire and Elena tried to figure out why Claire had such a smaller range of values in her report. First, they considered the proportion they used in the simulations. Elena says, my simulation used 0.7 as a proportion since I found that the proportion in my original sample. Claire says,
My simulation used 0.75 as the proportion. Since I found, I think that's supposed to be 0.74. We're going to change that. Okay? Since I found that the proportion in my original sample. The students used different proportions in their simulations. Do you think this is why Claire had a smaller margin of error? Okay, so looking back up here, we were told that Claire had a margin of error of 0.138. And then Elena had one of 0.280. Okay, so the question is, do you think this is why Claire has a smaller margin of error? All right, so smaller margin of error. So in order to find the margin of error, remember we take our critical value, we multiply by sigma divided by n, okay, in order to get our margin of error values, okay? So then we also have to think about the standard deviation. Claire had a smaller standard deviation, right? Like her numbers weren't as spread out, right? And so her numbers were kind of closer together, just a little bit, but that also results in a smaller margin of error. So in order to reduce our margin of error, we can increase our sample size, which both of these samples have the same amount, but we're just going to write these down. So to decrease or reduce margin of error, you can increase sample size, which means we would take 2,000 people instead of just 1,000. You can reduce variability, which is what happened here. Since our standard deviation is smaller for Claire, we're reducing our variability, okay? Or we could lower our confidence level. Okay, that's also something that you're going to see. So increase sample size, reduce variability, and then lower confidence level. Okay. So they looked for more differences in their initial sample and discovered that Elena surveyed 10 people in her initial sample and Claire surveyed 40 people. Do you think this is why Claire has a smaller margin of error? Okay, we just talked about this. So Claire used less, Claire used more people in her sample, so she increased her sample size, which is going to reduce your margin of error, okay? Because if you're increasing your sample size, that means you know more about the population that you're trying to study, right? Okay, so it's going to center in on the true mean and the true values that you should have. All right, so Han and Priya are studying the size of trees in the forest next to their school. They each take a random sample to find the proportion of trees that have trunk circumference greater than 4 feet. Tyler's sample contains 12 trees. Okay, so Tyler's got 12. And then Priya's got 20 trees. After collecting data, they run 100 simulations, and each to determine an estimate for the proportion of trees with large trunk circumferences. How do you think Tyler's reported margin of error compares to Priya's? Explain your reasoning. So remember, if we increase our sample size, we decrease our margin of error. So Priya is going to have a smaller margin of error. Okay? Two reporters are both interested in finding the proportion of people in town who are unemployed. They each collect a random sample and use proportion of unemployed people in the sample to run 100 simulations to determine a margin of error. The first reporter claims the proportion of unemployed people in town is 0.045 with a margin of error of 0.011. Second reporter claims that the proportion of unemployed people in the town is 0.037 with a margin of error of 0.02. Why do you think the estimated proportion of unemployed people in town is different for the two reporters? Okay, so why did they get two different samples proportions and then two different margins of error? The first guy
got 0.045 and 0.011. And then the second guy got 0.037 and 0.02. So this guy was a little bit smaller in his margin of error, right? So why do you think the estimated proportion of an unemployed people in town is different for the two reporters? Well, remember, they took random samples of people, right? And maybe the first reporter used more people in the sample. Oh, I'm sorry. Let me answer that question first. Why do you think the estimated proportion is different? Okay, so we're looking at 0.045 compared to 0.037. Well, if you take a random sample of different people, I mean, like same population, but you're going to get some variability. If I take 10 people and I take 3 of them in a sample randomly, I'm going to get some different results, no matter who I'm pulling, right? There's still variability, so it's still going to be around a certain area. That's why we have that margin of error, right? It accounts for those random samples. Why do you think the margin of error is different for the two reporters? That's the question I was answering. Maybe he increased sample size. Okay. Or maybe he reduced variability by pulling people from, a specific region, or he got it from different groups of people or something like that. Or maybe he lowered his confidence level. We're going to talk more about that a little bit later. Okay. A small random sample reveals that 4 out of the 20 high school students get the recommended amount of sleep at least 8 hours a night. After using a computer to run 5,000 simulations based on this sample, it's reported that the proportion of high school students who get the recommended amount of sleep is 0.202. Gosh, with a margin of error of 0.178. So how could this research group reduce the reported range of values? So how can they reduce that variability? How do you reduce variability? That's the question. Okay. Well, if we reduce that variability, don't we also reduce the margin of error? Right? Which, if we increase our sample size, we'll reduce that. Okay? So, hashtag reduce sample size. Okay? Is there any other ways we can think of? Well, we can lower our confidence level. So instead of it being, a 99% confidence level, we do 95% confidence. That will cover that 2 standard deviations. And again, we're going to talk more about that a little bit later, because I know it's a little confusing. Okay? So basically, big takeaway is the different ways that you can reduce your margin of error, which is really increasing your sample size. Knowing more about your population because you're pulling more people. Okay?